Hey there, and welcome. For literally thousands of years, we've looked up at the sky with a sense of wonder. But there's one thing up there that has totally shaped our lives, our culture, and even how we think about time. Yep, I'm talking about the moon. So let's get into it, how this silent partner in the sky became our very first clock.
So let me ask you something. Have you ever actually seen the moon during the day? Really looked at it? It feels a little weird, right? But it happens all the time. This exact thing happened to a young girl named Mira. She was at this amazing kite festival in Ahmedabad, kites everywhere, and she just happened to look up and boom, there was the moon, plain as day, hanging out in the blue sky. And seeing that just got her thinking, wait a minute, why isn't the moon only a nighttime thing? And how come its shape is different all the time? It's a great question, and honestly, it's not just some kid's question. This is the exact same mystery that pushed our ancestors thousands of years ago to basically invent astronomy.
I think we can all get where Mira is coming from. She knew the basics, right? The moon's a big ball, it reflects sunlight, but it just wasn't clicking. For a second, she even thought, is this an eclipse? But no, those are super rare. Her simple, huh, moment is really the start of a much bigger question. What is actually happening up there?
Okay, so the secret to all this is something we call the phases of the moon. And spoiler alert, it has nothing to do with eclipses. It's all about perspective. It's about where we are, where the moon is, and where the sun is. It's kind of like a cosmic dance between these three, and lucky for us, we've got front row seats right here on Earth. So let's just break that down. When we say phases, all we're really talking about is how much of the bright, sunlit part of the moon we can see from down here. That's it. It all depends on where the moon is in its orbit around us.
Now, this next part is absolutely crucial. The moon doesn't make its own light. It's not a lamp. It's a mirror. A giant, dusty mirror. It's just reflecting the light from the sun. So think about it. At any given moment, one half of the moon is lit up by the sun. It's daytime side. The thing is, we don't always get to see that entire lit up half from our angle.
And this is where we get to bust a really common myth. A lot of people think the phases happen because the Earth's shadow is falling on the moon. Nope, that's a lunar eclipse, and that's a whole different, much rarer thing. The phases we see every night, that's just us looking at the moon from a different angle as it goes around us, seeing more or less of its sunny side.
Here's a super simple way to see this for yourself. Seriously, try this at home tonight. You are the Earth, okay? Just stand in a dark room, get a lamp or a flashlight, and put it on the other side of the room. That's the sun. Now take a ball, hold it out at arm's length, that's the moon. Keep your arms straight and just turn around slowly in a circle. Watch the light on the ball. You'll see it go from fully lit to a little sliver to totally dark and back again. That's exactly what the phases are.
And this whole cycle, this whole dance, takes about 29.5 days. It all starts with the new moon, or Amavasya, when the moon is between us and the sun, so we can't see the lit side at all. Then the visible part starts to grow. That's called waxing. The Shukla Paksha, all the way up to a big, beautiful full moon, or Purnima. After that, it starts to shrink, or wane, during the Krishna Paksha, until it's gone again, and the cycle repeats.
So this cycle is super predictable. And that predictability wasn't just nice to look at, it was incredibly useful. For our ancestors, the sky wasn't just a place for stories and gods. It was the original clock. It was the most reliable thing they had to measure time and organize their entire lives.
Think about it. Nature basically handed us 3 perfect units of time. The Earth spinning on its axis, that gave us the day. The Earth going all the way around the sun giving us seasons, that gave us the year. And what about in the middle? That perfect 29.5-day cycle of the moon gave us, you guessed it, the month.
Okay, so now you've got your basic building blocks, days, months, and years. What's the next step? Well, you gotta organize them. You need a system, right? A way to know when to plant crops, when to harvest, when to party. You need a calendar. But this is where things start to get complicated.
Here's the big puzzle they had to solve. If you just count 12 of those moon cycles, or lunar months, you end up with about 354 days. But the solar year, the time it takes to go through all the seasons, is about 365 days. So you've got a mismatch. You're about 11 days short every single year. What do you do?
Well, different cultures tackled this in different ways. Some just went with a pure lunar calendar, super easy to track by just looking at the moon. But the problem is your holidays and seasons would slowly drift apart. Then you have solar calendars, like the one most of us use today, which is all about tracking the seasons and uses things like leap years to stay on track. But there's a third, really clever option, the lunisolar calendar. It's a hybrid. It uses the moon for its months, but then it adds a whole extra month every couple of years just to sync back up with the seasons. Pretty smart, right?
So you might be thinking, okay, interesting history lesson, but why does this matter to me? Well, it explains something you've probably wondered about your whole life. Why do some holidays, like Diwali or Eid, seem to fall on a different date every single year?
And the answer is simple. It's because those festivals, and many others like Holi, aren't based on the 365-day solar calendar. Their dates are set using those ancient timekeepers, the lunar or lunisolar calendars. They're literally marching to the beat of a different drummer, or in this case, a different orbit.
Let's look at a festival that uses a purely lunar calendar, for example. Because that lunar year is about 11 days shorter than our solar one, the date of the festival on our calendar actually shifts backwards by about 11 days every year. Over a few decades, that means the festival will travel through every single season.
So yeah, it really all boils down to that one number, 11. That's the magic number. That little 11-day gap between the moon's dance and the Earth's journey around the sun is what creates this beautiful, fascinating drift in how we celebrate around the world.
So for almost all of human history, we had just one moon. We watched it. We timed our lives by it. We wrote poems about it. But then, pretty recently, in the grand scheme of things, we started launching our own. I'm talking about artificial satellites, of course. These are our new moons, human-made objects that we've put into orbit around the Earth. There are new eyes and ears in the sky, and they have completely changed everything about life down here. I mean, just think about your day. The GPS that got you somewhere? Satellites. The weather forecast you checked? Satellites. That video call with someone overseas? Satellites. They help us do incredible things, from managing natural disasters with observation tools like ISRO's Cartosat to exploring the universe with space telescopes like Astrosat. We've gone from just looking at the sky to making it an essential part of our global infrastructure. And that kind of brings us full circle, leaving us with one last big thought. For thousands of years, our ancestors looked up at the sky to figure out time, to find meaning, to understand their place in the cosmos. Today, we're not just looking at the sky, we're filling it with our own creations. So here's the question. Hundreds or thousands of years from now, when future generations look up, what story will they read in the stars we've added? What will our new moons tell them about who we were?